Choosing a graph to fit a narrative advanced. For each scenario below, choose the graph that gives the best representation. You're going to read a paragraph and you're going to pick the correct graph that matches to that storyline you just read. But before you try to figure out what is the correct graph, you have to spend a little bit of time of looking at the variable and understanding what it's going to look like on this graph. There are three types of slopes you have to pay attention to. 1, 2, and 3. So the first one is increasing. The second one is constant, is staying the same. And the third one is decreasing, is going down. Now you want to think about what do these slopes mean in terms of population. So if the slope is increasing, that means that my population is increasing as well. If it's increasing, that means it's getting bigger. So if it's growing. This is like a flat line. And you have to think about what's happening to the population. If it's the same, it's unchanged, that means the population is not growing. So it's the same exact size population. And then the last one is a decreasing slope. So what does that mean about population? That means the population is going down, is getting smaller. And this is going to help you out because as you read the story, you're going to think about the population in terms of, is it growing, is it getting smaller, or if it's remaining the same. So it says here, the population of a large city remains constant for several years. So it's not growing, it's not getting smaller, it's constant. That means that your storyline is going to start off with a flat line. So you're going to go through and you can see here that this is showing growth, so it cannot be this graph. This one, it starts off with a flat line, so it could be that graph. It could be this one because that also has a flat line. So I'm just going to mark it because that does match up with the first sentence. Here, the population I can see is decreasing, so it can't be that one. So it starts off constant, and this is my first sentence. Let me read sentence 2. Then the population grows very quickly for a few years until the city becomes quite crowded. So the population is growing. That means that I should see this in the next line. It's going to be increasing. And if I look at both of them, they are increasing. This one is going up, and so is this one. So far, it could be either graph. And then let me read the next sentence. After this, the population still grows, but it grows much more slowly than before. So if I look at these next lines, it says here that it's increasing a little bit, and here it's staying the same. It's a flat line, same size. So it can't be this graph. It has to be this one right here. So that'll be my answer for this part. Let's look at the next one. So I'm going to erase these descriptions because in the next one we're actually measuring the height of a ball now, not population. So I want to interpret what do these lines mean in terms of the height of a ball. So if my slope is increasing, that means my height of the ball should be going higher. So it's going to be getting higher. Here, the height remains the same height. And then the third one is decreasing. So that means that it's decreasing, it's getting lower. Again, so think about the height of the ball in terms of these three descriptions. So is it getting higher, lower, or is it staying the same exact height? And that's what you're going to look for as you read the story. Here it says, a person standing on the ground throws a ball onto a flat rooftop. So someone's standing on the ground and they throw the ball onto a flat rooftop. So that means that if you're on the ground, you're going to be holding the ball at a certain height. It's not going to be at 0. And then you're going to throw it up. So that means that I should see that it's going to be getting higher. So if I look at these 4 graphs, this one is going up, this one is going up, and this one is also going up. This one is not. It's just saying that the height is the same, but that's not true in our story. So I could exit that one out as an answer. Next sentence, the ball rolls around for several seconds. So it's on the roof, it rolls around. So if the ball's rolling around on a roof, you could just imagine the ball on a roof. If it's rolling around on the roof, that means that the height is going to be the same. So the next part, I can see that the height should be the same. the height should be the same, and the height should be the same. So it looks pretty good so far. Now the next sentence says, then the ball falls off the roof. So if the ball falls off the roof, that means that it's going to get lower, the height. So I should see the next part, decreasing. So if I look at this graph, it's still going in the same direction, so it can't be that one. This one is going higher, so it cannot be that one. This one is going down, so it has to be this one. So that'll be my answer choice for this problem right here. Let's look at another problem. In this problem, we are going to measure distance from John's house. Same exact thing as before. I'm going to draw my 3 types of slopes. I have an increasing, a constant, and a decreasing slope. Since we're talking about distance from John's house, I have to think about what do these mean in terms of that distance. So I'm going to draw a little quick sketch to kind of help me interpret what's going on. So here's John and his house, and I'm going to think about, if I'm going this way towards the house, my distance should be getting closer or smaller. Since the distance is getting smaller, I'm getting closer, so my distance is decreasing. That means that would mean it should match up with this one. So a decreasing slope would mean that I'm getting closer to the house, right? My distance from the house is getting closer. In this case, if it's the same, that means my distance from the house is unchanged. That means I'm in the same exact spot. I'm right here. My distance is not changing. It's the same. So I am, you could say, standing still. And then this one, if I'm going in this direction, my distance is increasing because I'm getting farther from the house. Therefore, in this case, that would mean that I'm getting farther, right? An increasing slope in this case matches up with distance because I'm going away, so it's increasing my distance. Let's look at the problem. John leaves his house on his bike. So if you're leaving the house, that means you're going away from the house. So if I'm going away, my distance is getting farther. So I'm going to look for an increasing slope. Looking at these graphs so far, this one cannot be an answer because it starts off with a standing still, right? The slope is horizontal. But it could be either of these 3 here. I can see this one is increasing, this one is increasing, this one is also increasing. But one thing you might notice is that it says that he left his house. If you leave your house, that means that you actually started at the house. So when your starting point is going to be at 0. And if I look at these 2 graphs, I notice that these 2 graphs here have a starting point of 0. This one starts off a little bit higher than 0. So actually I could eliminate this graph too, because it's saying that he left his house. So that means it has to be either this one or this one. Let's look at the next sentence. He rides at a constant speed until he reaches a lemonade stand, where he parks his bike and takes a rest. Since we're measuring distance, I can see that in that sentence, he's parking his bike and taking a rest, which means when you're resting, you're not getting farther, you're not getting closer, you're standing still. Therefore, the next part should be a horizontal slope, and I can see that I have that for this one and this one. So far, it could still be either one. Look at the next sentence. Then he turns around and rides home as fast as he can. So if you turn around and go home, that means you're going towards the house. Therefore, your distance is getting closer. So that means I should see a decreasing slope in the next part. And since this one is going up, I know it cannot be this one. This one is going down. Therefore, this has to be my answer choice right here. Let me erase these variables so that way we look at the next problem, in which we're going to be measuring, actually in this one, speed. So I have to think about, what do these slopes mean in terms of speed? So if the speed is increasing, that means you're going faster. If the speed is the same, that means you're going the same speed. So I could write same speed for that one. And then if you have a decreasing slope, that means your speed is decreasing, meaning you're going to be going slower. So as I read the problem, I'm thinking about, is the speed going faster, slower, or staying the same? Rita rides her skateboard up a hill at a steady pace. So the steady pace lets me know that I'm going the same speed. So it should start off with a flat line. This one is not a flat line, so because it starts up, so I can eliminate this. It could be this because that's starting off with the same speed. This one is going faster, so I can eliminate that. And that one is also going faster, so I can eliminate that too. So I actually already have my answer. But let me read the rest of the paragraphs to just double check that it does match up. After reaching the top, she stops and rests. So if you stop and you rest, that means that you're not going faster. You're not going the same speed. You did have to slow down quickly and then come to a stop, which means your speed is going to be at 0. So here I can see that slowing down, right? So you can stop. You stop, and that means your speed is the same for a while, right? Because you're resting. So that means that my speed is 0 for a little bit. So the resting is saying that it's the same speed once I stopped. And then the next sentence says, then she skates downhill at an increasing rate. So if your rate is increasing, that means you're going faster and faster, which would be this type of slope here, increasing. And I can see that's what we do have here. It's going up. One thing I just want to point out is that some people may get confused on this part where it says she skates downhill. So some people may think that because you're going downhill that it would be this type of slope. But this is why it's important. You got to understand what are we measuring. And in this case, we're measuring speed. So as we read the problem, we were just thinking about, are we going faster, slower, or the same speed? So that's why I didn't think about the downhill part. I looked at this part, which says increasing rate. And that's what you got to do for these problems. Just make sure you interpret what the slope would be in terms of the variable.